I want you to find the following. Number one, mean and standard deviations. Number two, median. Number three, I want you to find the mode. And number four, z-score of 29. Okay. And what does it mean? I want you to try this. Now, and when you do this, you could just use the formula for mean and add everything and divide by the number of items. You could also calculate the standard deviation by subtracting the mean, squaring all the values, and then taking the average of that. That gives you the variance, and you have to take the square root. But I also want you to know how to use your calculator to do the same thing. So you can go to the calculator, stat, and you can change L1, right, and put all these numbers in there. Okay. And then you do one variable stats, and that immediately tells you the mean and the standard deviation. Okay? So that's what I would like you to do.
Use calculator?
Yeah. So I advise you to use the calculator to do number one. However, to do number 2 and 3, you would actually need to, for median, you should order this from the smallest to the largest and see which one comes in the middle. This one has odd number of terms, so the middle one is just that. But sometimes you might have even number of terms. In that case, you have to take the average of the middle too. And then for the mode, you have to know which one repeats the most. And then you know the z-score, right? So I'll give you some time to do this. I'll be right back.
Oh, you saying Iraqi?
Yes.
Standard deviation, how many decimal points is what?
Just two decimals. Should be fine. Hundreds. The nearest hundreds. Okay, so let me tell you how to do it with the calculator. First, go to Stat, and then click Edit. And number one, Edit. And then go to put numbers in L1. So put these numbers in L1. 5, 11, 7, 23, 49, 21, 7, 28, 29. Okay. And then once you do that, you quit. So second quit. Quit. And then you go to stat again. So then you have to, once you're done with putting all the data, you have to go to stat again and go to calc. And then you look for one variable stats. Okay. Do that. And make sure that the list is L1. And here we don't have a frequency list, right? So in the frequency list, just delete. Okay. If you put that, if you have some data there, it's going to cause incorrect answers. So for the frequency list, you don't put anything. Okay. It should be blank. So I just clear that one. And then if I do a calculate, and then here's what we get. X bar equals to 20. Guess what this is? That's the mean value. However, it's a little confusing. It even tells you the median. Okay. It's a little confusing because there are two values that looks like the standard deviation. So Sx is 14.317. Or let's just say, let's just use hundreds, nearest hundreds, okay? And sigma x is 13.498, so it's like 50.
On the exam, are both acceptable as long
Yeah,
as we
yeah,
can't
so-
say
so,
which is which?
Yeah, oh, these? No. There's only one correct
So it's
answer.
just
The second.
It's the second one.
Yeah.
Okay. Now,
Okay.
can anybody explain what's the difference between these two? Yes.
One sample, one's population.
So this one is for sample, and this is for population. What do you mean by that, though?
I know the formulas are different. I don't remember why.
Oh, okay. So if you are thinking about how this data itself is spread out, you use this measurement, standard deviation. However, a lot of times, your purpose is not just about the sample. You want to know something about the entire population, okay? So if you want to know how the population variance will be like, or what will be the population standard deviation, then the sample's own standard deviation always underestimates. So you have to somehow change that to make it, like you correct it to make it bigger. And that correction is the difference in the formula is that instead of the sum of the x minus mu squared, and you divide by the n and take the square root. This is the formula for the standard deviation. You put this n minus 1, and because the denominator shrinks, the overall value increases. Okay? So this estimate is proven mathematically that this is a better approximation of the population's variance. Okay? And as before, I hope you understand that when you get a value from the sample that gives you an inference to what the population value would be like, it's always your best guess, right? You can't know for sure unless you have a total census. If you only have a sample, so you're trying to come up with a value, and it just turns out that this is the best guess. You have to modify this by n minus.
Is that the sample or the?
This is the formula for the sample. The top one is the sample, and this one is the standard deviation. And because in this question they are asking for the standard deviation of this sample, this data that's presented to you, you have to use this. Because we're not in a situation where the context is like you have a sample, tell me what the population's variance is or standard deviation is. Okay? That's not what this is saying.
So the sigma x would be the.
This will be the answer.
Okay.
Yeah.
Uh,
Yes.
I forget, which one is sample and which one is population?
Top one is the sample.
Okay.
Oh, by the way, when sample and population both come up in a question, the population values are given in Greek letters, and the sample's values are given as Roman letters, okay? And when there is no reference to the population, when the purpose is not about getting or predicting the values of the population, you treat the given data as the entire population. That's why we use this one, okay? The given data is thought to be the population. Okay. So the answer for the first one is mean would be 20, standard deviation is 13.50. Okay. Now I thought that the one variable stats doesn't give you the median, but it does. That's interesting, okay? So the median is 21, according to my calculator. Or you could just order this from the least to the max. So 5, 7, 7, 11, 21, 23, 28, 29, 49. So if you see this, you can see that 21 is right in the middle, right? You have 4 that's less, 4 that's above, so this is right in the middle, so that is indeed the median. Okay, what's the mode? 7, yes, because that's the one that's repeating the most. Yes, what's your question?
If you scroll down on the one variable stats, it does give you the median.
Yeah, so that's what I was saying.
Okay.
Yeah, you can get the median that way. Yeah. But if you didn't use a calculator, the way you would get it is by doing this. Okay, and then z-score of 29. What do you do? Right. So 29 minus 20, and you divide it by what? 13.50. So let's see. Second quit. Let's do this. Actually, it's just 9 divided by 13.5, right? 9 divided by 13. Okay, so I get 0.66. Something like that, okay? So that's what we get. And what does it mean? It means that 29 is 0.667 standard deviations away from the mean, which is 20. Okay. Now, is that a lot? No, not that much. If it's within 1 standard deviation, that's pretty normal, right? If it's 2 standard deviation or more, that's not so normal. Okay. So that's another thing that you can think of. Yes.
Can we do an example that includes the sample? Like a question that would include the sample?
Oh, okay. So you're interested when we get to use this. That's for exam 2.
Oh, okay.
So in exam 2, it's about inference, which means you use the sample values to predict the values of the population.
You
Yes.
said it means 29 is 0.67 standard deviation away from the mean.
Yes. Or more than the mean. So
More.
let's state it so you can write it down. Okay. So what does it mean? It means that 29 is 0.667 standard deviations more than the mean. Mean value, which is 20. Okay. Uh-oh.